So this video is the first lesson for chapter 4. So in this lesson we're going to look at gravitational force near Earth. So a lot of it is theory based, so I don't have all of the slides from the note. You can read that stuff from the textbook, and then if you still need help, just feel free to ask in class. Really the important thing today we're going to look at is what's going to happen when our normal force doesn't equal our force of gravity, because up until now we've always been assuming normal and gravitational forces are equal, and so there's no vertical movement. And so now today we're going to be looking at some vertical movement. So just to look at air resistance and free fall. So just first of all, free fall is the motion of a falling object where the only force acting on it is gravity, and so no air resistance. And so that means the object will accelerate. And if you look at the first image here, it's a multi-flash photograph of a ball in free fall. And what you'll see is that the spaces in between the balls is getting larger, and that's showing us that we have an acceleration. In the second picture, we have those helicopter seeds that come from our maple trees. And what you can see is that the distance between those is about the same. And that's because it's got air resistance acting on it. And so it's affecting our rate of acceleration. So when we have a normal force that doesn't equal a gravitational force, our free body diagrams can look a little bit different. So here we have a drawing, a free body diagram for something rolling down a hill. So let's there's our hill. And then we're going to have to draw our box that represents our free body diagram. And so the force of gravity is always going to be down with respect to our object. But the normal force is perpendicular to the surface. So what we need to do is if you're using a ruler, you can draw a dotted line so that it's forming a 90-degree angle. And then that's going to be our normal force. And so we have an angle there being created. And we're not going to look at solving force diagrams with an angle in this course, but you will experience that in future physics courses. So let's look at another example. So we have a 60-kilogram person in an elevator that is accelerating up at 2.6 meters per second. So let's write down what we know. So we have a mass, 60 kilograms, and we have an acceleration of 2.6 meters per second squared. And it's asking us to determine the normal force acting on the person. So let's go ahead and draw a free body diagram. So we have a normal force acting up, and we have a force of gravity acting down. And so I want you to think, like if you've ever gone up the CN Tower or any other tall building where the elevators tend to go really fast, you get kind of that little bit of lift. And so that lift is actually because our normal force and our force of gravity aren't balanced the whole time. So let's write an F net equation. And in this case, we're going to just reverse how we've been doing it in the past. So we're going to do our normal force subtract our force of gravity. Remember, you can always replace F net with MA. We don't know what our normal force is, and we can replace FG with mg. So we have a mass, we have an acceleration, and we always have our acceleration due to gravity. So we can go ahead and we can solve for those amounts. But let's rearrange first. So we're going to do MA, and then if we bring the mg over to the other side, it will become positive, and then we get our normal force. So I'm going to actually move over a little bit so that I've got more space. So Fn then is equal to our mass times our acceleration plus our mass times our acceleration due to gravity. So let's go ahead and solve. So we're going to put our 60 kilograms, 2.6 meters per second squared, plus 60 kilograms times 9.8. So when you do that, you would get 744 newtons. And we'd want to round that to 2 sig figs, so let's go ahead and round it down to 740 newtons. And the direction there would be up, because our normal force always acts up. So that's just a quick look at gravitational pull. Again, the note has some more information about acceleration due to gravity, and it's how it changes depending on where you are on planet Earth and how it relates to skydiving. So make sure you have a check through that note, and if you have any questions, let me know.